revisited. So the purpose of this lab was to further explore the charges on charged tape calculated in Lab 1 and to use a more sophisticated computational model in order to determine a more accurate charge and magnitude of charges on a charged tape during floating point. This model will explore distribution of charge along the tape versus modeling the tape as a single point charge as done previously. Some of the fundamental principles are distribution of charge using infinitesimally small pieces of charge along the tape, dq, electric fields in superposition from Lab 1. I'll get into that in a second. Newton's second law concerning how when momentum is constant, the forces are going to be equal, and thus the magnitude of our gravitational force and electrostatic force will be the same, and Coulomb's law. So a brief example of the final result was the magnitude of charge Q on one piece of tape was 2.56306 times 10 to the negative 8th coulombs in this lab versus 1.34431 times 10 to the negative 8th coulombs in labs 1, which was about a 1.9 times increase in the charge of the tape. So the experiment in our computational model is going to be different from Lab 1. Now we're modeling each tape as a distribution of point charges versus in Lab 1 we were modeling it as a single point charge in the center of the tape. And our goal was to calculate magnitude of the electric and gravitational force again. The experimental model is remaining the same as Lab 1, so for that, our initial conditions were our system were tape B, our surroundings were tape A and the gravity. Tape length was 6 inches, tape mass was 0.1524 grams, and the distance between the tapes when tape B started floating was 0.033 meters. The procedure included creating tape A or B by pulling tape off of the base tape, giving both tapes charge, hanging tape B's ends on an elevated surface, and bringing tape A from below close to tape B until repulsion occurred and tape B floated. So the Lab 1 computational results were the magnitude of charge on one piece of tape were 1.34431 times 10 to the negative 8th coulombs, and our magnitude of gravitational force and electric force were equal, being 1.494 times 10 to the negative 3rd newtons. And of course that was due to Newton's second law. And assumptions in Lab 2 were that we're going to ignore air resistance on a moving object when calculating force due to gravity, assume that each U-tape had the same amount of charge Q due to the law of conservation of charge, and this is the one assumption that's different from our previous lab. Our charge is now distributed evenly throughout the piece of tape rather than being treated as a point charge. So in our experiment, this is my glow code. You can see the Q from Lab 1, and we estimated Q for Lab 2. I plugged in values until a magnitude of electric force equaled magnitude of force due to gravity. We defined our E field function, which we had used in previous labs, and you can see the formula for an E field there. And then this was the one thing that was different. We're actually creating a line charge at each individual point charge in this code here. And you can see then we initialize top tape and bottom tape, and we create, I used n equals 50 point charges. So each piece of tape will consist of 50 point charges this time. And then we created our E scale factor, so the arrows were more visible. We calculated our E at dq, our electric field on the top tape, and our force of electrostatic on the top tape by summating each individual infinitesimal pieces electric fields and respective forces, and that was how we got our net electric field and net force. And you can see in our result, we have our electrostatic force pointing upwards in the positive y direction, our force due to gravity pointing downwards in the negative y direction, and then all these green arrows are the individual electric fields of each of the system's point charges. And our final result, of course, as mentioned earlier, was 2.56 times 10 to the negative 8th coulombs versus previously 1.3 times 10 to the negative 8th coulombs. So what if we had modeled each of our tapes as a single point charge like in the previous lab? So if we had done that, the point charge estimate in our previous lab was 1.3 times 10 to the negative 8th. Our line charge estimate is 2.56 times 10 to the negative 8th. And our line charge estimate is 1.9 times larger than our point charge estimate. Why do these estimates differ? It's because our point charge estimate assumes all of the charge on the tape surface is located at one finite point in the center of the tape, when in reality the line charge is closer to the real value because it models charge as a distribution across the tape surface, which is closer to how the charges are arranged in real life. Therefore, the line charge estimate is closer to the real value. Some of the errors were inaccurate charge due to human contact, environment, and air contact. The assumption of QA equals QB could be incorrect. The size of tape will not exactly be the same, and our initial condition measurements could have been off. Some of our differences were our point charge assumption was less accurate than our line charge assumption. Environmental factors mentioned above occur in real life, and simulation doesn't take these into account, and our charge in real life may not have been exactly the same as the charge on the model. Thank you.